Hello everyone. At the end of the previous video, we saw how we can use matplotlib.rc params in order to set various aspects about plots. We set the font size to a value of 18 instead of the default value of 10, which enabled us to produce a slightly better plot. In this updated version, we are clearly able to read the x-axis tick labels, y-axis tick labels, and also the title. Let me show you how we can change the figure size. That is very different from changing the font size, correct? When you change the font size, all of the text associated with the plot will become bigger. But when you change the figure size, the entire plot gets impacted by that change. I'm going to copy paste the first 3 lines of code into the next cell. The way that we can mention figure size is by including the figure size parameter into plot function. My apologies, this should be parameter instead of argument. Let me go ahead and fix that. This particular example has the plot function of bar. So we are going to mention fig size parameter. What's going to be the argument for that? That's going to be a tuple of 2 values. Recall that you define a tuple using parentheses, and also that tuple is just a immutable version of a list. The first value is going to be the width, and the second value is going to be the height. It takes some time for you to poke around a given plot in order to come up with the correct aspect ratio for width and height so that the plot is not too elongated. I can show you the width and height values that I came up with for this particular plot. So my width is going to be 1.5 inches and my height is going to be 4 inches. The plot looks slightly better than before, correct? One problem with that though, all of the bars are thin and long. Wouldn't it be nicer if the bars were horizontal instead of the bars being vertical? That's very easy to do with respect to a bar chart. You can simply say bar h instead of using the bar plotting function. Couple of things which will go wrong right away with that is that all of your figure aspects that you're trying to set needs to be flipped around when you flip the figure itself around, right? So you're flipping the entire figure in a horizontal way. So your fig size should now have 4, 1.5 as the tuple of arguments, and setting y label should now become setting x label instead. Right, that's so much better. The next thing which I want to show you is how can you change the color of your bars in your bar plot. I'm going to keep pasting the same set of lines here so that we can keep applying new things to the same example plot. The parameter for that is color, and color can be defined using multiple different ways. First thing is that you mention a string color, let's say red. Let me copy paste this updated version. Now your bars are all red. The second thing that you can do is you can mention short form representation of a color. For instance, blue color is small b over here. That's just going to produce blue bars. So if blue is small b, what is black? Black is k. So that's going to give you black bars. Other than the entire color name and the shortened version of the name, you can also mention just a scale of color that will enable us to produce a grayscale plot. I'm not sure how many of you have encountered a colorblind person in your life. It's often recommended that you make most of your plots accessible to colorblind people so that they can differentiate various bars that you have in your plot. At least that's definitely the recommendation in the field of computer sciences. Let me show you how you can produce a grayscale plot. You can do that by mentioning a number instead of mentioning different names for the colors. For instance, if I say 0.5, that's going to show me a grayscale value of 0.5. The next thing which I want to show you is how can you make grid lines show up in your plot. It's very simple. You can just simply say axis subplot, which is ax dot grid, and that's going to show the grid lines for you. Let's talk about a couple of other things. There are a lot of unnecessary margins in this particular plot, correct? When you try to add this plot to your research report or any kind of report that you're typing, it might be nicer if you don't have the top margin and the right hand side margin. That might just make the plot more readable. Again, all of these aspects depend on individual taste. If you go through my publications, it's likely that you'll learn how I like to produce plots. The way that you can set the top and the right hand side margin is by using something which is called as ax.spines. Let's go ahead and look at what is there inside ax.spines. You'll get a list of 4 values. Each of those values represent each of the margins that you have for your plot. So if you want to set the top margins visibility, you'll have to say ax.spines dot not dot off top, and you should say set underscore visible, and you should pass a value of false. Similarly, if you want to set the right margin to be invisible, you can use the right value inside your list over here. Notice that it has a list of tuple values, so we are just accessing the second value by mentioning the first value over here. Right, that got rid of the top margin and the right margin for us. The final thing which I want to talk about with this particular general example is that how can we capture subplots? Why exactly is this useful? Imagine that you're writing a report where you're generating multiple different plots and you want to be able to apply some common aesthetic aspects to every single plot in your report. Wouldn't it be nicer if you can write a function in order to apply all of those aspects to all of those plots? That's what subplots will enable us to do. And we are going to have to import something which is called as pyplot in order to be able to access subplots. The way that you do that is you're going to say from matplotlib import pyplot, and it's commonly renamed as PLT to be the short form. I'm going to scroll all the way up to the top so that I can do this import at the beginning of the notebook file. Right, once you import PLT, let me show you how you can access the access subplots. You can simply say plt.subplots, and that's going to enable you to access subplots. When you do this, you're going to get an empty plot because you're trying to access subplots for a brand new plot over here. You can capture the return value and try to display the return value here. So the return value has a tuple of 2 values. The first one is going to be the plot figure and the second one is going to be the axis subplot. Clearly we are interested in the second value over here because we want to write a function which enables us to do some aesthetic settings with axis subplot. Let me go ahead and define a function called get underscore ax where I want to do some settings with a specific axis subplot. So I can say plt dot subplot and subplots, and if I want to have different arguments, those are going to go inside this particular function. The first thing which I want to do is I want to be able to define a figure size, correct? So I'm going to take this tuple values over here. Instead of hard coding the height for this particular plot, let's say that I want to configure that as an argument to my get underscore ax function. So you want to be able to maintain the same width for all of your plots. The reason for that is it's typical to have every single plot in your document to have the same width. Especially if you have the LaTeX 2-column format, you want to stick to 1-column width size exactly. So I'm going to use a hard-coded value for the width. Width is the first parameter, and I'm going to vary height, and I'm going to define a parameter called height inside my get underscore ax function over here. Let me define a default value of say 3. Recall that subplots function returns a tuple of 2 values. I'm going to show you how you can directly unpack a tuple. So you can capture that value into a single variable. Let's say that I'm going to call that as retval, and I can try and print retval over here. So if I call this function get underscore ax, that's just going to give me those two return values, right? So I can access the first one by saying retval of 0, and I can access the second one by saying retval of 1 over here. List indexing works in a similar fashion in tuple indexing as well. The first one is a figure and the next one is the axis subplot. Instead of using one variable to capture the return value here, whenever you know how many values are present within a tuple of return values, you can directly unpack them. The term unpacking just refers to the fact that you'll be using two variables with a comma separation here. So I can say fig comma ax equal to that, and if I now print fig and ax, you're going to see the exact same output as we saw before. We are only going to need the ax variable here. The figure variable is not really useful for us. So one thing which you'll find a lot of programmers doing is that whenever they have a variable which is useless, they'll just use an underscore to name that variable. So that just denotes that that value is not being used at all inside this function. What do we want to do with the axis subplot object over here? We want to be able to set things like, let me see, the visibility aspects, for instance, right? I'm going to copy those. So the title and the x-axis label or the y-axis label is specific to certain plots. You can imagine defining different parameters to take care of all of those, but I'm not going to do that, and I'm just going to stick with the width height aspect ratio over here. So I can simply say ax dot spines of top and set the visibility to false over here. I'm going to go ahead and return axis subplot object to the place where we are calling the function. Let me capture the return value over here, and I'm going to say 1.5 is my height over here. Once I do the setting for my axis subplot, I can create my bar plot by passing the axis subplot as an argument to the plot function. You might be able to guess that the argument for that is the parameter for that is ax. So I can simply say ax equal to ax over here. I'm saying for the parameter ax inside the bar h function, pass my argument variable ax. And once I get the return value from the get underscore ax function, I'm going to be able to set title and x label. As I mentioned before, you can also set those inside your getAX function by defining appropriate parameters for that, but I'm just not going to do that. You can explore that on your own. Right, looks like we were able to reproduce the same plot as before.